Hello, in this video I want to share with you a demonstration involving water pressure, atmospheric pressure and gas pressure. Okay, now the inspiration behind this video was that last week on the way to class, I accidentally dropped my water bottle. Okay, and as a result of that, actually my water bottle had a pretty big crack at the bottom. Okay, and I was observing how the liquid leaked out of the water bottle, and as we will see later, it actually helps us to demonstrate some concepts that we learned about pressure at the secondary level. Okay, now just give me a moment, I'm going to fill this up. So, as you can see, I filled the water bottle up. You will notice, right, that over here, when it's closed, the leak is relatively slow, but when the leak is, when the cap is opened, it starts leaking at an alarming rate. No trickery involved, pure physics. Okay. Now, in order to understand what's going on, we have to cut to the whiteboard. Okay, so let's go to the whiteboard and let me show you from a secondary school understanding of pressure how we can explain this phenomenon. So now we are here at the whiteboard, and before we analyze the specific situation of the water bottle, let's do a quick recap on some pressure topics that we learned in secondary 3. Okay, firstly, let's talk about atmospheric pressure. Now, atmospheric pressure, if we consider that we are all at sea level, the atmospheric pressure should be around 1.03 times 10 to the power of 5 pascals. And this is a constant value, so that means this constant amount of pressure will be pressing against all the surfaces that are exposed to the atmosphere. Okay. Now, next concept that we want to recap is hydrostatic pressure. That means, which refers to the amount of pressure due to being submerged in a liquid. So the hydrostatic pressure that you experience will be the product of H times rho times G, where H is your depth, right, the vertical distance downwards from the surface of the liquid, times rho, the density of the liquid, and G, the gravitational field strength. Okay, and the last concept that I want to recap is that of the pressure of a fixed amount of gas. Okay, so if we have a fixed amount of gas, the pressure and volume of the gas, when you multiply them, you will get a constant value. Okay, and so what this means is that if you have a gas and you trap a fixed amount of gas inside a container and you force the volume to decrease, then the pressure will increase, and the opposite, vice versa, will happen as well. Okay, so this is an important point to remember for the second example later. Okay, so let's look at the first case, right, where we have the bottle with the cap open. Okay, now when we are thinking about whether or not water gets pushed out of the leak, right, the main thing that we are concerned with is what is the pressure on the inside of the bottle, right, like over here, versus the pressure on the outside of the bottle, right? If the pressure on the inside is greater than the pressure on the outside, then of course this pressure pushes the water out, and vice versa. Okay, so if we look at the source of pressure on the inside of the leak, right, what we have is that on top there is a certain amount of atmospheric pressure pushing down on the surface of the liquid, and then in addition to that, there is also pressure due to being under the liquid. Okay, and this pressure here is given by H times rho times G, right? So the total internal pressure is basically this atmospheric pressure plus the hydrostatic pressure, H rho G. Okay, and on the external side, you only have atmospheric pressure pushing up and resisting it. Okay, so just by looking at this comparison, right, you can easily see that you have atmospheric pressure on both sides, inside and outside, and on the inside you have this additional hydrostatic pressure, H rho G, right? So obviously the internal pressure is always going to be greater than the external pressure, so water is going to keep getting pushed outwards, right? Okay, so the interesting thing is the second example where we have the lid closed. When the lid is closed, then instead of having atmospheric pressure here, you have some amount of air pressure or gas pressure, right, which may not be equal to atmospheric pressure. Why may not be equal? Because once you close this cap, this region here becomes a fixed amount of gas. More gas can't come in anymore. Okay, so this is a fixed amount of gas. So this concept here, number 3, this applies. Okay, this fixed amount of gas, when water leaks out, right, this water level is going to go down, it's going to drop. And as this water level drops, then the volume here, this volume of gas, what's going to happen as the water drops? The volume of gas is going to increase, right? And when the volume of gas increases, then the pressure of the gas here will decrease. Okay, so the pressure of this gas here is going to be something that's less than atmospheric pressure. Okay, and so this is important. So if we do a comparison, considering when the lid is closed, we have pressure of the trapped amount of gas plus, again, hydrostatic pressure H rho g, and we are going to compare this with atmospheric pressure on the external side of the lid as well. Okay. Now, the important difference between this and the previous example is that this P gas, right, is going to decrease. This is going to decrease when the water level drops. So now we know that this gas pressure is going to be less than atmospheric pressure. So there will be a point, right, where this pressure decreases to the extent that the total pressure on the inside here, P gas plus H rho g, is going to be equal to the atmospheric pressure pushing in from the outside. Okay, so if we think about what's happening at this point here, right, you have a certain amount of pressure inside, certain amount of pressure outside, right, and this amount of gas here can change, can decrease, right. When these two are equal, then there is no net force that's going to be pushing the liquid out anymore. And so this is how we explain the phenomenon using Sec 3 and Sec 4 physics concepts. Okay, so I hope everybody has found this video informative and helpful. And thank you for watching, and I'll see you in the next video.